Good afternoon.
Good afternoon, sir. Okay, good afternoon, everyone. We welcome you to this session 12 of the 5-day FDP, where we have again Dr. Chandrakanta Sahoo, sir, who will be speaking about hypothesis testing using non-parametric test. Over to you, sir.
Just a minute.
Sure, sir.
Ah, Welcome back. So now, hopefully, how many? This one only 54, including myself. Okay. Am I audible?
Yes, sir.
Yes, sir. Okay. Is the screen visible?
Yes, sir.
So we'd like to make a quick recap of what we have discussed in the morning sessions. Okay. So anybody who can uh, just make a recap or summary what we have discussed as far as parametric and non-parametric tests are concerned. Okay, fine. So basically, that when we have certain kind of data, okay, and we are doing research and we are looking for data and we have conducted already, that means we have already collected data. And prior to data collections, what we have done, we have developed certain kind of hypothesis. Okay, and we want to test the hypothesis. Okay. So, what we will do, based on the nature of the data, based on the questionnaire design, because when we design the questionnaire we have certain things in our mind, because this is my objective. I want to test whether there is a significant difference between x and y. Okay. Whether there is a significant difference before one treatment and after one treatment. Accordingly, when we design the questionnaire, a tool normally we keep in our mind. So we must understand the theory behind that this test. Okay. Number one, while using a parametric or non-parametric test, we have to process our data to understand the nature of the data. Take for example, basically two kind of tests that we must do before selecting the particular kind of test. One is normality test, whether your data is having one normal distribution curve, present one normal distribution curve, or your data is having a skewed distributions. That means your data is either dominated in the left side of the curve or right side of the curve. It is not a normal distributions. When you have a normal distributions, what do we do? Normally, we prefer to use parametric test. If we have skewed data, means your data, or let me cite another example to better make you understand things. Suppose you are using a scale 1.5 scale in data collections. Most of the respondents, like 60-70% respondents they have given like response like 1, 2, 1, 2, 3, 1, 2, 3, 1, 2, 3 kind of things. It is not 4, 5. Okay. So in that case, your data will be that your curve will look like it is, but it is skewed. That is left side your data is dominated. But when you have like sometimes this may happen in faculty feedback as well. Also. Okay, students will give based on the faculty. No, everybody 4, 5, 4, 5 kind of things. That will also right side your data will be skewed. So what happens? You are having the data. You are getting responses 1, 2, 3, 4, 5 kind of okay. All like um, whole scale has been used 1, 2, 3 all it will normally in certain that proportion, so in normally it will present the normal distributions. So in that case select this parametric test, okay? And another test you have to do, that is called homogeneity test. Homogeneity tells about that whether your data is spread disperse, how disperse your data is there. So you see, in the morning I was showing this, like one concert is doing several programs. You see the sound range. This is the sound range, very less. You see, but you see this is the range. The sound is very the range of the sound. If you see, it is reaching to different like areas. The spread is more, so therefore the data is here heterogeneous. Okay, and here also homogeneous. Okay, these are the basically normal. So you can do this when assessing normality. You can do this histogram. You can visual display. You can check histogram or PP plot. We have seen in the morning session also QQ plot. Okay, then skewness and kurtosis you can see like the normally zero. It has to be in normal distribution or plus one or minus one. It is also okay. So then you have also case test. You can do also case test, and in case test, your p value has to be but non-significant. If it is non-significant, means normal data. If it is significant, it is not normal data. So these are the basic things that you must understand before selecting this. And what is the questionnaire design that we did? In the morning sessions, we have seen. I would like to. See, there these are called these are called independent sample test. Okay, two sample. Suppose take for example boys versus girls, or city customers versus urban consumers versus rural consumers. Okay, so you can have also higher income group and lower income group, and you are checking how much they spend towards certain things like grocery, how much they are paying. So one likewise. So these are you will find here the sample is independent. These are not inclusive. Yes, these are different. Boys and girls marks are different. Okay. So but here what happens? You are doing one treatment before and another treatment you are doing after. Okay, there is a treatment. Okay, what is the treatment? Take for example, I was telling you that example in the morning sessions as well. So the treatment is that suppose some patients have come to the doctors and the doctors want to treat them, and these patients are suffering from obesity diseases. Obesity disease. So doctor took the baseline weight measures and doctor gave them a treatment like that every day the person suffering from the disease obesity must walk for 5 kilometers and follow a diet plans. Okay, so this is the treatment that doctor is giving. After that, what is happening? After 1 month, he is checking the weight. So whether there is significant difference in the weight before and after the treatment or not, that we are going to check. Understood? So here it is paired t test. Why it is called paired? Because the that respondent is observed or measured twice. The same person is observed twice, before and after the treatment. But here this is not happening. In my class, take for example, there are both boys and girls are there, and what they have a score. In my paper, take for example, some HRM paper I am teaching, and they have got certain scores. Okay, I would like to that test whether there is a significant difference in the mark of boys and girls. So here questionnaire designing is very much different, and here also questionnaire design is different. You see, so research design matters here. The research instrument that you are going to use when you develop a questionnaire, keep in mind what kind of test that you are going to use. Okay. So here what happens, your data has to be normal, your data has to be normal, and your data has to be also what? Data needs to be homogeneous. Okay, the spread we are talking, that homogeneity of variance spread we are talking, it should not be dispersed. So here, when your data is like, you can see skewed kind of distortion, you can see this is skewed distortion. Look at the pictures. So you have data right side concentration. So here this. So independent test you have a substitute if your data is not normal or not normal. That means you can prefer Manhattan test. In case of pair t-test, if data is not normal and homogeneous, you can prefer also this Wilks functions kind of test. Is it understood? This is the basic difference. Okay. So before selecting the test, what you need to do, you have to process this. So you have to make at least two kinds of tests, one normality test and another is homogeneity of variance test, level test. You need to. Achha. Here what happens, you have ANOVA, your sample sizes, boys and girls, we are talking about two samples. Okay, here what happens, more than two samples, like take for example, incomes of or spending habit of the people belonging to higher income group, lower income group, and middle income group. Three samples, it becomes, three group samples it is becoming. Okay, similarly, suppose take for example, that benefits that citizens are drawing from government. Okay, you are taking, what are the strata you are taking? You are taking strata as like SC, ST, OBC, and others, or generals, you can see. So four groups. So just the difference between this independent t-test and ANOVA is that your group sample is 2, it is more than 2. It can be 3, it can be 4, it can be 5 also. Again. So this is the difference. And when your data is not normal, when your data is not normal and not homogeneous, then you have another kind of test, Kruskal-Wallis. You can run it. Are you getting? Kruskal-Wallis you can use. Similarly, here also this is two sample, paired sample, like before and after treatment. So what you did here, your design will be like that. So baseline survey you did. A doctor did the baseline measures like that when a patient is meeting the doctor is taking the measures. Suppose take for example, one person is getting 100 kg. Okay. Then given the treatment after 1 month, so he becomes 92 kg. So after 2 months, he becomes like 90. After 3 months, he is becoming 80. Are you getting? Or whatever may be. These are just the assumptions I am talking about. Okay. So likewise, some 20, 30 respondents are there. Their baseline survey after 1 month, after 2 months, after 3 months, that weight measures have been taken here. Okay. Got it? So this is it here, pair t-test and repeated measures, only difference is that sample. It is two samples, it is more than two samples. Okay, it can be 3 samples, it can be 4 samples like you baseline, month 1, month 2, month 3, month 4, kind of thing, or month 5, it can be like that. Understood? So if the data is not normal and homogeneous, you can go for this. Got it? Understood? Yes or no? Tell me. Respond.
Yes, sir.
Sir, I understand this is very difficult time to keep you engaged. in post-launch sessions. However, you must respond, na? Otherwise, how can I know that you listen or you understand? Okay. Okay. So in the previous session, this is important. We'll see repeated measures ANOVA. Okay. We have like on data. We'll see parametric. It was parametric repeated measures ANOVA. We have a case. This is called diet. Okay, you can see. So this is the exact test that case I was discussing. There is a doctor and there are many patients. Many patients, means 15 patients are there, and they are suffering from a disease called that's called obesity. And when these patients approach the doctor at first, what the doctor did, measure the weight. This is the baseline weight, like 105, then 102, like this. Then after that, in first month, the respondent one has been measured. It is found to be the person is having the weight 95. Then in second month, it is 92. Then 75. Accordingly, it is there. Okay. So all these 15 respondents uh, weight has been measured for 4 months. First month is baseline, then first month this is 0 months means baseline, then first month, second month. You see there is a reduction. You see there is a reduction. That means it is working. It seems it is working, but we have to test it whether the difference that is uh, being made, okay, through these interventions, whether that is there is significant difference or not. Okay, that we have to do. So the first step that we need to do is that we have to run the what test. Two kind of test. One is normal test, that is called KS test, and another is what homogeneity test. But here we cannot take the homogeneity test. Why we will not be able to take homogeneity test here? The reason being, you see, even if in case of paired sample t-test, so we are not taking this like homogeneity test because there is no factors there. Like male, female, if you see, strange variable, that is called strange variable, is absent. Therefore, we will not be able to take. So here we'll check on the normality, statistics, descriptive we can take, then plot we can make, histogram we can make. Okay, you see normality. Now here you see 11 tests, it is completely disabled because we have not selected any strange variable here. We don't have strange variable here. We have not taken whether the person who is suffering from obesity, whether he is a male or female. Okay. Just we are giving the treatment irrespective of their gender. So normality test, we will see options. Okay, there is no missing case. Okay, so no, we can. You see. So what we'll do, we'll see the skewness kurtosis. You can see here skewness kurtosis. It is 0.8 and 0.5. It is okay. Okay, the range has to be in between +1 and -1. Therefore, this data is okay. Then wait after 1 month. You see this is also okay. You can see. Okay, minus 0.453 and here also minus 0.226. Okay, then to second months you can see this is also skewness and kurtosis. It is between +1 and -1. After 3 months you see this is also between +1 and -1. Okay, you can check the case test also significant value everywhere it is greater than 0.05. That is what is desirable in order to consider our data is as normal. Okay, that means this data is okay. This data is fit for parametric test. Okay, so this is the design. Research has made the questionnaire design and collected the data, and that means this data is suitable for what? This is suitable for uh, parametric test, that is called repeated measures. So now we'll do the repeated measures. So what we'll do? What are the steps? We'll select analyze. You can follow the steps, dear friends. So this is how you can do analyze, general linear model, then here repeated measures. Are you able to hear me?
Yes, sir.
So everybody is here. Please do practice with me. This is important. Any of the times you may need this. You see, it is four factors: baseline, month one, month two, month four. I will write here as number of labels. It is four. Add. Okay. Four labels. Okay. Then you can define this. Okay. For this, all fours, what we can do, we can import here. Okay. All four we have imported. Then we can have model. Nothing. We don't need anything. Then let us see contrast. In contrast, you can here you can check repeated measures. Yes, repeated. Please do with me. It is in contrast. Then contrast repeated. Then change here. Then continue. Okay. So then you can check plot. You don't need any plot here. Okay. Then post-hoc. Post-hoc we don't need because we are not going to compare this. Okay. We don't need. Okay. Then save. Okay, this these are required basically on residual and predicted value. These are required in case of regressions. Okay, we don't need anything. So then we have options. Okay, in options we can have this. These we can import overall and factor one to display mean for because we would look like to have the mean here compare main effect. Okay, you can tick. Then let us see. We can check here one for any. One for any we will see because we will look for the comparison baseline and 1 month, then baseline and two. These are the comparison we will do. Then we can have like transformational metrics, then restrictive statistics we can take. Then if then homogeneity test also we can do here if you want. Okay. Continue. Okay. Then it's fine now. Okay. You see. So dependent variable 4, you can see this is the mean. Okay. Mean, baseline mean 102, then 93, then 85, then 69. That means it is working. It seems it is working. Diet plan is working. The treatment that is given by the doctor is working. But we have to see that whether this treatment is significant or not. This is the sample size 15, 15, 15, 15. We have taken 15 means overall because this is actual 15. Because the same persons is observed or measured 4 times. Okay, then you can see multivariate. Okay, multivariate. This is also not important. What is more important is here. Okay, this is important. Muscle test. Okay, so this is the degree of freedom. Degree of freedom. It is written 5. How it is 5? It is becoming 5. Can you tell? Because we have 4 factors. Because it is taking in comparison actually. Number of comparisons. Number of comparisons because when we have 4, we are having 6 comparisons and minus 1 is 5. This is chi-square value. This is okay. What is more desirable is that this has to be non-significant actually. This has to be non-significant. But it is here significant because it is less than 0.05. Okay. Therefore, what we need to do? Okay. Non-significant means What does it mean? That means there is no significant impact of diet plan on weight reductions. Okay. But it is happening here. If you see, it is happening here. When this value is non-significant, what happens? So we can do this greenhouse geyser and wound field. These we can sum up, we can take the average. Okay. Please understand this when we have much less test of sphericity. Okay. So in that case, when this value is becoming non-significant, because significance is what is desirable. Okay. It is sorry, it is becoming significant. I'm sorry, it is becoming significant, but it is what is required. It has to be non-significant. It has become significant because it is less than 0.05. So in that case, what we can do, we can take the average of greenhouse geyser and wound fields. So when we calculate this, means plus means 0.581 plus 0.656. So when we take the average by 2, okay, so we'll get that the value will be also what greater than 0.05. Okay. Is there any questions? Okay. Great. So this value we are taking here the average. When we take the average of these two values, we will get the value something that is greater than 0.05. Therefore, this has become but non-significant. Okay. Achha. And finally, we'll see just hold on. Monthly test, we'll see. This is important. So you have to interpret this table actually. Okay, we have to interpret this table. So this is now becoming non-significant. Okay, this is what is. So here in this case, we can report what? What we can report here? You can report here. You can see this F value test of between subject. F value is it is given, and here significant. This is significant. Okay. Are you getting? So you can report this. Okay. That means what is the case here? Our null hypothesis tells that there is no significant difference in weight. Okay. As far as when you give the treatment, like a diet plan you are giving, or certain kind of interventions that when you are giving, there is no significant difference. Okay. It's null. Null means there is no significant difference. But what we are finding here, there is significant difference. You can see a value is is found to be 5944.22. This is found to be significant. Okay. So therefore, that means the treatment given by the doctor is having significant impact on weight reductions of the patient suffering from obesity disease. That means the treatment is fruitful. Okay, that you can. Okay. So, is there? Have you ever anybody that use this repeated measures, Sanova? Okay. Many of the that maybe participants are not aware of this. Okay. This is just the pair sample t test. When you see Pairs, it is two sample. When you have more than two samples, you can use this paired sample. In pair means same respondent is observed more than two times. Okay. So then, any questions that you have, or we'll move to next test that is called non-parametric test. Very fast, we have to wrap up, otherwise we will not get time. Okay. So then we'll move to Manhattan test. You can see Manhattan test, as it has been discussed, that it is the substitute for independent t-test. Independent t-test. When your data is not normal, not homogeneous, you can opt for this Manhattan test. So this non-parametric test, what it does actually? The basic difference when you see how it works. So here these are the mean test. Okay, from mean it is taking. But here when you don't have your mean doesn't fall on the middle, means your data is not normal. So what it does, makes the rank of the value. Suppose take for example the student, particular student, I am making a test of the students, the total mark is 50. Okay. So in that case, what happens, many of the students who will be scoring like 30, 30, 30, so 30, 40, multiple of students will score the same score. They will get the same number. In that case, what will happen? So all these values or the marks will be ordered in a ascending order actually. Okay. And then there will rank will be given. Suppose take for example minimum mark or minimum mark has been given 30 and two people have got 30 as mark. Okay. Or three people have got that 30 as mark, or two people, take for example two people. So what would be their rank? It cannot be one and one. Okay. So in that case, uh, that one will be given one, another should be given two. But in between, like 1.5, 1.5, that is given as a rank. Okay. So this is how, therefore, it is called rank test. Okay. So we'll see now. We'll move to non-parametric test. I have shared one that is called depressions. See, there is a case also. Let me show you the case. Case is depression. Okay. Basically, what happens? A psychiatrist might collect data to investigate the depressant effect of certain recreational drugs. He tested 30 clubbers in all. 15 were given tablet to take on Monday night, and 15 were given the drink syrup. Okay, there are 30 clubbers. Okay, so 15 were given tablet and 15 were given syrup. So whether which is actually more effective, that we want to check. So level of depression was measured using the tested scale, and the day after Tuesday and Friday. Okay, we'll see. This is the case that we are going to discuss. You can see the tablet users, 15 users are tablet, and another 15 were also to see these are syrups. Okay, you can check variable view. So drugs, type of drugs, you can see it is here. One we have quoted as tablet and two per syrups. Okay, so these are tablet and syrups are in nominal measures, and this depression has been taken as scales. Okay, so basically you can see 70 samples we have. We'll check now. First we'll run for normality and homogeneity check. Okay. So this is has to be dependent list. This is a factor. Okay, here we will put it as factors. Okay, why factor? Because this is a strange variable. Tablet and syrup, these are not numbers. Therefore, we are putting here as factors. Then statistics, we can have descriptive statistics. Then we can go for normality and on transfer. That is a 11 test. Let us not check histogram, the same thing. Okay. Then here, what is there? Nothing to do. Then we can go for OK. So what we are checking here? We are checking, you can see skewness and kurtosis. You can see it is more than +1 and -1. It is more than 1. Okay. So here also, this is okay. This part syrup is okay on Tuesday, but this data is not normal. Okay. Then Friday tablet, you can see this is also okay, normal. Then syrup data, it is not normal. Okay, it is more than +1. Therefore, it is not normal. So, in that case, in order to run parametric test, all data has to be normal. Therefore, the data is fit for non-parametric test. You can see test of normality. It is 2, 2, 2. This is C, significant, but these are non-significant. This is what is required. Test of homogeneity, you can see based on mean. If you see, it is point. This is okay, but this is not okay. Okay. So we can conclude the data is not normal and not homogeneous. Okay. So let us follow the process. So we will do now the Manhattan test. Manhattan test, let us remember that this is a non-parametric test. Okay, this is the non-parametric test. It is the substitute of independent t-test. Okay, you can go for Ligas dialog. You can see. Okay. Everybody, please do it. So after that, you can go for two independent samples. So by default, we are getting here monotony U. Okay. So what we'll do? These are two test variable list. Okay. So group, we can take this as group. Okay. How many groups? One is syrup, another is tablet. So we can write as 1 and 2 group. Continue. Okay. Then we don't need to do anything. Okay. Then options, you can take this descriptive. Okay. Then we can go to this. You can see this. Tuesday, if you see, total 30, 30, 30. Okay. So Tuesday mean is 18. Okay, 18.43. This is also Friday also 21.37. Okay, this is minimum, this is maximum. Okay, this is ranked usage. Ranked mean is different usage. Okay, for tablet, Tuesday is different. What is this ranked mean? If you see, okay, just hold on 1 second.
Proportional character
Okay, just hold. Yes, welcome back. You can see this is 15, this is 15, this is 15, this is 15. Okay. Descriptive statistics, it is clear. Then this is the rank. You can see what is mean rank. Can anybody tell? I have already told this. You see. Let me do one. So if you see, sort variable. You can see. So this is, you can see, I will show you one ascending order. You can see this is ascending order. All responses has been put here. So you see tablet, then syrup, okay, then all tablet you see. So accordingly, suppose this is, see this is 1, okay, 13, 13. You can see, you can put it as 1.5 and 1.5. Okay, that you can do. Then this is 2, you can write 2. Then it is similarly after 2, it is 3, 3.5, 3.5. You can take the average of this 3.5 and 3.5. And accordingly, what we are getting, these are called the mean rank. Okay, because since the data is not normal, these are skewed data. What is, so these data are ranked here. Okay, and after ranking this data, the mean of the rank is being taken here. This is how it happens. Okay. Monotony. This is therefore it is 17.53. It is also 13.47. You see. So this is tablet. This is syrup. There is not much difference on Tuesday, but when you come to this Friday, you see there is a huge difference. Okay, there is a huge difference. This means data is now here mean rank is 22.67. It is 6. It is 8.33. There is a huge difference. Okay, understood. So you see that means on Friday, Tuesday it is not working that effectively, but on Friday it is working that. So how do you check whether this difference is significant, whether this difference is significant or this difference is significant? You have to come to this test statistics. In statistics, you can see monotony, it is 82 if you see. But your significant value, if you see 0.2, okay, 0.2 means it is not significant. Okay, it has to be less than 0.05 in order to call it, in order to consider this as significant. That means on Tuesday, drugs didn't have enormous effect. Okay, but when Friday data, if you see, you can see monotone, U value is 5, then it is significant. It is 0, means it is less than 0.05. That means the drugs that has been given to the patient that was not that effective on Tuesday, when they continued these drugs, it has been found that drugs has been effective on Friday. You can see the difference. Friday also mean rank difference is huge, whereas on Tuesday the difference is not that huge. Therefore, this is not that significant, whereas in Friday it is significant. This is telling. So you can report in research report what null if you see there is no significant difference. Okay. And here also, if you see the H1, that is alternative hypothesis, there is a significant difference. Okay, so in the first case, if you see Tuesday case, there is no significant difference, means null hypothesis is accepted. As far as Tuesday is concerned, as far as Friday is concerned, it is not. There is a significant difference. H1 is accepted. So you have to that report in your research report this non-written value, U value is 82, and significant value on Friday also same thing. It is 5 and significant value. Accordingly, you have to include. This is how actually non-routine test. I think very since normally what happens, we are more aware of this independent t-test and paired sample t-test, but whereas we must understand this whether the data when we collect certain kind of data, whether the data is suitable for t-test or other it's a substitute kind of test, non-parametric, that is called non-routine or Wilcoxon test. Okay. So this we must understand. Okay. Any questions from non-routine test? Okay. So Wilcoxon test, we'll see. Next one is Wilcoxon test. You can see this is Wilcoxon test. This is the substitute test for this paired sample t-test. Okay. Why this is the when the data is not normal and homogeneous, we can have this. The questionnaire and research design will remain the same. Okay. That means it is before and after treatment that we are getting here. Those who want to practice, you can open these cells. Okay, there is one. Let's see. There is a retailer. A retailer wants to know the impact of print advertising on sales. Is it happening actually? Print advertisement, does it happen? Does it impact sales? And because he is making some investment, he has been doing on advertisement, he is putting for sales promotion, he is making that, putting some money on that, and he wants to see whether the print advertisement has been an instrument of sales or boosting sales or not. Okay, so 1 month advertisement has been done, then after that what happens, into the sales data has been collected. Okay, in different stores. You can see this is the before and after. Before advertisement it is 6,000, after it is 1,05,000, then it is 9,000, then it is 11,000, 25,000. There are difference. These are difference. Okay, here you see it is 90,000 before, after that it has been reduced 6,000. Okay, in one store. Okay, then here 4,000, after that it is increased. So it is 85,000, then it is 5,000. It is reduced after print advertisement. So these are the kind of data. So 9,000, 7,000, 10 retail outlet, these have been, the data has been collected. Indeed, these are all simulated data. Okay, these are not real data. Okay, but for the sake of understanding and using a kind of test, this data has been created. Okay. So first thing that we can create this explore. Okay. So dependent list, statistics, you can check. This is fine. This is factor, normality. We can check the normality. Then histogram we can also check. This is same thing that we have been doing. Then Levin test, because since we don't have strange variable, we cannot run this Levin test. Then options. This is fine. Nothing we have to do. Then both statistics and plot we'll see. And see the data here. Very quickly we'll wrap up. This we have seen in the morning session. You see, kurtosis and skewness, it is more than 1, so it is non-normal. Okay, then after that you can see here after print it is also, it is more than 1, it is also not normal. Okay, so you can see test of normality, it is also it is significant. This is not desirable in case of parametric test. That means the data is not normal. Okay, similarly if you see, you can see the histogram, you can see This you can element. Okay, element show distribution curve. As you see, this is also skewed distribution. This is not a normal distribution. See, in all the way, if you see, this data is not normal. Therefore, this is not suitable for parametric test. So now we'll do this Wilcoxon test. So how to do? We have to, this is analyze, then we have non-parametric. Okay, under non-parametric we are getting legacy dialog. Okay, and follow with me if you are practicing. Then two related samples, two related, because this is related, before and after related samples. Okay, so then after you can here before then after. See, okay, what we can do here, nothing is required, and check options. You can take descriptive. Okay. Then okay, before print advertisement you see it is 24,000. Now after print advertisement it is 26,000. It doesn't look that there is enormous difference. Okay, but we have to check whether this difference is significant or not. Okay, so mean rank we have seen before and after it is 4.9 the similar way, because all data that responses that were collected, these have been given the rank. Okay, and there is that mean of the rank has been taken, therefore it is 4.90. Then here also we are getting after is 4.90, then before it was 6.1. Okay, sum of rank, that means all the ranks have been summed up here. Okay, this has become like 24.5 and here it is becoming 30.5. Okay, so this is mean rank we are getting. Okay, then let us see the test statistics. Test statistics, descriptive statistics. Test statistics you can see. So after and before you can see Z value is found to be minus 0.306, whereas significant it is 0.7. It is significant or non-significant? Can anybody tell, interpret? Anybody who can respond to this? Yes. How do you interpret this? Z and this significant value. What we are doing? The purpose of this research is to understand whether the print advertisement has an impact on sales or not. Hypothesis that we are developing that there is no significant impact, null, and H1 or alternative hypothesis is there is a significant impact. Got it? So here we are getting, you see, the Z is minus 0.30 and your significant value is 0.760. This is non-significant. Non-significant means that means the print advertisement doesn't have significant impact on the sales. This is clearly visible if you see also. So mean before it was 26,000 and after print advertisement it is becoming 26,200. Only the difference of 2,200. This difference is not significant. This is how you can that interpret. Okay. Any questions? So here we can do now Kruskal-Wallis test. Okay, this is a substitute for ANOVA actually. This ANOVA. Okay, this is a substitute for ANOVA. What kind of data that we need for this? We need like here ANOVA. For this, more than 2 samples data. Okay, this can be different caste, SC, ST, OBC, and this can be also like different income groups, higher income group, lower income group, middle income group. Okay, more than 2 samples that we need. If the data is not normal or homogeneous, that you can have this. Okay, the research design remains the same. There is no the questionnaire design. There is no difference. But thing is that we have to check whether the data is normal and homogeneous. So accordingly, we can do. So this is the case study. Okay. A scientist has discovered that caffeine consumption linked to a higher heart rate. If somebody is consuming caffeine or coffee, so that means his heart rate will increase. Okay. Researchers took 40 participants and split them into 4 groups that varied in the number of caffeine consumption. The first group was in a control group, that means it was not given any coffee. Then second group was having 1 coffee per day, and third group is having 2 coffee per day, and final group is having 4 coffee per day. Okay, at the end of the month, all the participants were measured heart rate score. This is the case, you can see. Okay. So we have coded this variable view, you can see. So the number of groups is here 1, 2, 3, 4. Okay. Then you have also heart rate that is also measured here. This is scale, this is nominal measures, because this is a strange variable. So you can see here, these are the coded as 1, 2, 3, 4. Okay. 4 groups, total 40 is group comprises of 10 respondents. Okay. You can see. Okay. So first let us check descriptive statistics, then explore. Heart rate will take to dependent list, coffee consumption, because this is strange variable, here we can take. Then statistics, descriptive statistics, then plot, you can check histogram, normality test, on transpond. This is called Levin test. Okay. So then options, if you want to check, nothing to do here. Okay, then we can go for okay. We'll check here. Skewness and kurtosis. You can check the skewness and kurtosis here. It is, you see, this is exceeding. Okay, it is going beyond, means it is not between +1 and -1. Therefore, the data is not normal. So here you can see it is also, you see kurtosis. It is not in between +1 and -1. It is also, you can say, not normal. This is fine. Skewness and kurtosis in between +1 and -1. 4 coffee for a day, you see this is not. Okay. So if you see here, test of normality, case test. Okay. Significant value, if you see this, these are called non-significant. Okay, these are called non-significant. But if you see the homogeneity of variance, if you see these are becoming significant. Okay, so both normal data is if you see data is normal, if you see the data is normal here, okay, but it is not homogeneous. So in this case, we must have the data, okay, normal data and homogeneous data also we need to have. Therefore, the will run for this critical values test will run. Okay. So this is the process: analyze, then non-parametric, then legacy dialog. Okay. After legacy dialog, it is k independent sample. Okay. So you can see the coffee consumptions. You can put it here, define range. How many groups are there? 4 groups. Okay, first group is no coffee. Second group is 1 coffee per day. Third group is 2 coffee per day. And fourth group is 4 coffee per day. Therefore, we will write here as 1 and 4. Okay, then continue. Then heart rate score. This is numeric value you can bring here. So this is exact. Okay, we don't need to do anything. Okay, then options. You can take this descriptive statistics. We can check this. Okay, you can see it here. So heart rate score 40, 40. Okay, number of sample is 40. Coffee consumption also 40. This is mean 10, 10, 10, 10 we have taken. Therefore, it is 40. Then mean it has been found heart rate score is 87 and it is 2.5. The minimum, this is the minimum, this is the maximum, this is the minimum, this is the maximum. Okay, 1 and 4. These are the 4 groups that we are talking. Okay. So then you can see rank. When we did the mean rank means we arrange the data in ascending order. Okay. We arrange the data in ascending order. Okay. So here it is mean rank. When we arrange the data in ascending order, what happens? Then we took the mean of this rank. This is in case of no coffee, it is becoming 16.35, and this is for 1 coffee, then 2 coffee, 4 coffee. So this is how it is done. Then test statistics, if you see heart rate score, chi-square test, it is, so you can see this is 12.453 and degree of freedom is 3. Okay. Then it has been found that it has been found significant. Okay. So what is our hypothesis here? Our hypothesis is that we want to study the impact of coffee consumptions on heart rate. Therefore, we have that collected data from four groups. The one is control group, that means that is having no coffee, and second group is having 1 coffee per day. Third group is having 2 coffee per day, and fourth group is having 4 coffee per day. And it has been found that when people consume coffee, there is a significant impact on heart rate. That means when a person continues to consume more coffee, in that case, we will find that their heartbeat will increase accordingly. Okay, this is how we can conclude. So in your research report, you can put this score. Chi-square value is 12.43 and degree of freedom is 3. Why 3? Because 4 group minus 1, it is 3. Then significant value is less than 0.05. Therefore, coffee consumption has significant impact on heart rate. Okay, is there any concerns? Is there any question that I can address? Okay, fine. We will take a short break of 5 minutes. Then we will resume the sessions. Welcome back. Am I audible?
Yes, sir.
Okay. So then Pradman Anuva. You can see this Pradman Anuva. So this Pradman Anuva is the substitute for repeated measures Anuva. Okay. So basically, when we select a tool and we have certain kind of data, and we are using parametric or non-parametric test, we select two kind of tests. Okay, before selecting the kind of tools that we are going to use. Like for example, we have the data will run for normal reject and homogeneous, also homogeneity of variance test. Okay.
Sir has got disconnected. I think he's facing some issues. He will get back to us soon.
Okay, welcome back. So am I audible now?
Yes, sir.
Actually, where the connection got disrupted? Could you please tell me? Anybody? So Friedman ANOVA, have you checked? Have you seen or not? Friedman ANOVA, or we'll start once again. Or before that, it got disconnected. Like when we are discussing about Puskal Wallis. Coffee case study we are discussing. 1 coffee, 2 coffee, no coffee, 4 coffee. Or it is just a marketing campaign that we are discussing, Friedman ANOVA, so that we can start. Actually, I could not notice. In the morning, I was taking sessions from my home. Then I came my college. I forgot to bring my that earphone. So here I collected one and I was taking the sessions. And somewhere that battery died. That happens. So okay, let me uh, start once again. This one. Let me share the screen. Screen is visible or not? Not visible. It must be. So it is in
No,
their screen.
no, sir.
No, sir, not visible.
Okay. Is it visible now?
Yes, sir.
Is it visible?
Yes, it is video now.
Okay, okay.
Yes, sir.
Thank you for your patience. Because I could not understand where it got disrupted.
Actually,
So
the connection was disrupted for a long time. Actually,
then I should have received a call. Huh? So what is the case study that we are discussing earlier when it got disrupted? Could you please tell me so that I can start once again? Or the final one, I will go for that Friedman ANOVA. I was discussing Kruskal Wallis in the previous case. Okay, one coffee
Yes, sir.
case.
We heard that thing, sir. No coffee. You were discussing about that because I have the screenshot with me. So it
Acha,
was from past from 4:15. You were disconnected, sir.
for 15, okay. The last 15 minutes, okay.
Yes, sir. Last
Okay, we'll
15.
start once again. No problem. To test, we'll run.
Sure, sure, sir.
Okay. This coffee case. Hopefully, my screen is visible to all. Coffee. Let me close this one. Kruskal Wallis. To tell you. So this is actually this Kruskal Wallis is the substitute for this ANOVA. That means when your data is not homogeneous, not normal, you can go for this. You can use this Kruskal Wallis. Okay. So before using this test, what we need to do, we have to see our data. We have to check our data that these are whether these are normal or normal data or homogeneous data. We have to check. Okay. So there is a case that we are discussing, and there are some research papers. It has been found that caffeine consumption is having tremendous impact on heart rate. That means what does it mean? When we consume more coffee, our along with the consumption of more coffee, our heart rate also increases. Okay. So therefore, the researchers want to test this. Based on some literature review, he has found that caffeine consumption is having impact on heart rate. Therefore, he wants to test it, whether it is true or not. Okay. Therefore, the researcher developed null hypothesis that caffeine consumption doesn't have significant impact on heart rate, and H1 age alternative hypothesis, the researcher developed that it has the significant impact on heart rate. Okay, so this is the data view. This is the you can see variable view, coffee. Okay, the persons you can see. I have coded this. There are 4 groups of people have been selected. The first group has been given no coffee. This is called control group. Second group has been given 1 coffee. Third group has been given 2 coffee per day. And fourth group has been given 4 coffee per day. These are the 4 groups. And this is the strange variable. This is nominal in measures, and this is also scale. In scale we have taken. Okay. And see the code is reflecting here. This is 1, 2, 3, 4. You can see. So how many? This is 40. Total n equal to 40 means 10, 10, 10, 10. 40. 4 groups 40. So when group 1, okay, no coffee, the heart rate is found to be 60. Then second respondent also 81, then 94, like this. So 2 coffee 75. These are the heart rate. These have been measured. Okay. Now we would like to check with the hypothesis that we have developed. Okay, whether it is null is true or alternative hypothesis is true. Before that, we have to see that the data is normal or homogeneous. Homogeneity of the data and normality of the data we have to check. Okay, what we will do? Analyze, then descriptive, explore. Okay, then coffee consumptions. This is 1, 2, 3, 4. We will take to factor list. This is a heart rate. We will take to dependent list. Okay, so this is descriptive you can take. Then plot you can do, like normality check you can do, and histogram if you want you can do, or we will go for Levin test on transpond. Okay, so then options, not required to do anything here. Then we will check it. You can see the control group. First we will see no coffee. So skewness is okay. This is also, it is beyond. This has to be in between +1 and -1. So this is not normal. 1 coffee per day. Second group will see this data is also not normal. It is not between +1 and -1. You can see -1.25 it is. 2 coffee you can see kurtosis here. This is normal in between +1 and -1. Okay, this data is normal. 4 coffee you can see. So this is also not normal. Okay, test of homogeneity you can see. This is non-significant. This is okay, non-significant. Okay, what is desired? But let us see the Levin test. Okay, Levin test if you see, this is has found to be significant. Therefore, the data is not suitable for parametric test. Okay, that means in case of parametric test, this has to be greater than 0.05. This is okay. This part is okay here. Case test, but this is not okay. You see, 0.001 is there. Therefore, this data is suitable for what? Non-parametric test. Okay. So these are the basic things that we must check first. Okay. So let us see. This is 1, 2, 3, 4 groups. These are the heart rates. Now we will run the Kruskal-Wallis. Kruskal-Wallis is the substitute for ANOVA. Okay. So now it is analyze, then non-parametric test, then legacy dialog, then K independent sample. Okay. Now you can see this is coffee consumption. This is the strange variable. You can take this. How many groups are there? 1, 2, 4. 4 groups are there, maximum 4. Then continue. Then heart rate will import here. Then exact. So nothing is required here. Options. So descriptive you can take. If you want quartile also you can take. Then Kruskal-Wallis by default it has been selected. Okay. We see. Descriptive statistics. This is 40 sample we are taking. Heart score rate overall it is 87. So minimum is 61, maximum is 110. You can see heart rate score no coffee, it is 16.35. You see, what are the difference? How much difference it is coming? You see, 87 and this is 16 point. Why this difference? Because this mean is different. This mean is different. This 87 has been taken. How this has been taken? You can see the mean of these. Okay, the mean of this total. Okay, but here when you have the mean, this is the rank mean. How rank mean has been given? Means the data needs to be arranged in ascending order, then rank is assigned. Suppose two respondents have got the same values. Okay, so they should not be given different ranks. They have to given the same rank. They suppose 1 and 2 respondents are have got similar like 20 take for example. These are the ascending order. These are in the first and second. They are the first and second respondent. So you have to give the rank as 1.5 and 1.5. It is not 1 and 2. Okay. So accordingly, the rank has been taken for no coffee, then 1 coffee 19, then 2 coffee. You see, it is 2 coffee, then 4 coffee. It is 4 coffee. It is increasing really. Okay. Test statistics, this is important. Okay. Chi-square test value, it is checking 12.45. Degree of freedom is 3. How? Because 4 groups minus 1. It is 3. Then significant. This value is significant, less than 0.005. That means the literature survey that the researcher has done, what the literature survey says that when somebody consumes more coffee, that means his heart rate is likely to increase. This is proved here. Okay, like how do you how do you report or what do you report in your research report? Okay, so this value must be reflected. The report you have to write that campaign
Sir,
consumption.
sir, wonder.
Yes.
Sir, first mean rank is 16. Then 2 coffee it is 19.
Hmm.
3 coffee it is 14. Then
Hmm.
4 coffee is 31. So
Hmm.
how can we say that the heart rate is increasing due to its mean rank? Because when it is taken 3 coffees, then mean rank is 14.65.
Hmm.
Then how it is increasing order?
Now you have to see this. Actually, this is simulated data. These are not real data. Okay, these are not real data. Okay, this can happen. In real data, actually, you will get the patterns. Okay, for the sake of running the test, it has been designed. So there is no logic behind this actual pattern. If you go to the field, actually, you collect real data, you will get the patterns. So this is, once again, let me tell you, these are the mean rank. Okay, mean rank means ascending order. Suppose group 1, take for example. Okay, group 1, let us see. This is group 1, you see. These are ranked together here. Okay, so you will get some rank here. Then here also you will rank. Okay, 2 also rank. So here you see the lowest value is 65 is given rank 1 or 61, sorry, rank 1. Here the lowest rank is something, it is 62 has been given the rank 1. Got it? Separately these are given. Are you getting? Hello?
Yes, sir. Yes.
So rank has been given for this no coffee. No coffee calculation has been made. Then true coffee, 1 coffee calculation has been made. So these have not received 40 has not been given, if you see the simultaneously. So 1 coffee first rank given. Then 2 coffee once again rank 1. It will start from rank 1. Getting? So this is how it is different. So then you see, I think it is clear. Chi-square, so basically what you need to see, this is significant value. That means what it tells? It tells that there is a significant impact of caffeine consumptions on heart rate. This is how you can conclude. Okay. Sir, actually, if you see, there are many other factors are also influencing. For heart rate, it is not just coffee. Sir, are you able to understand?
Yes, sir. Yes, sir.
And there are many other factors are also influencing here. Okay, but we are keeping all those factors silent here. Okay, because that will be a very robust kind of study if you are putting many factors here. Okay, so only we have taken based on a literature survey, those the people who are consuming more coffee, they are likely to get more heart rate, and that one data set we have created and we are testing it. That's all. Okay, there is the, if you see, these are not real data that you can take a conclusions and uh, that these are eternal truth. Save content. Acha. Very quickly, we'll finish the last one. This is for marketing campaign. Last one, you see. Sir, this is a data set. This is a data set. There is a company that thinks that it needs marketing campaign, and therefore it designed a marketing campaign, and uh, it did the campaign for 1 month. Okay. After 1 month, it studied whether the marketing campaign that was initiated by the company had a significant impact on sales or not. Okay. Therefore, what it did, you can see at the start, data view. Okay, at the start, these are the value like 64.98. Okay, it can be in, then it is 68.16. It can be thousand or millions, whatever you say. Okay, then it is 57 point this. Okay, that means you say at the beginning, before the marketing campaign, the score was high, was 64.98. After 1 month, it is becoming 68.16 and then 57.95. Accordingly, there are 15 stores are there. Their sales amount has been collected. Okay. So the same thing, the same process that you can follow. Let me not repeat this process because we are running short of time here. So you can follow the same process like descriptive statistics and explore, and you can check all these things at your own end whether the data is normal and homogeneous. Okay, but I have seen it these are not normal. Let us otherwise let us check. Second, 2 minutes of okay. Descriptives, then plot and see normality check we can check. Okay, because Levin test we cannot check because there is no strings data. Options, nothing is there. Then okay, you can see 15 15 15 stores. Okay, there is no missing data. You can see skewness. This is okay, this part is okay. Then after 1 month, this is also okay. And this is, if you see, after 2 months, this data is not okay. Kurtosis, it is not in between +1 and -1. Okay, we'll check the normality. Test of normality, we will check. Test of normality, this is, you can see, 0.2, not significant. Okay, this is okay. This is also okay. But kurtosis, there is some problem. Okay. Okay. However, we'll see it. We'll use it. So what we'll do, analyze non-parametric test, then legacy dialog, okay, then k-related sample. Okay. This is for Friedman ANOVA. Okay, here what we'll do, we'll check all this. We'll bring test variable at the beginning, that after 1 month, then after 2 months, then exact, not required to do anything. Statistics, we can take this descriptive. Okay, Friedman by default it is there. Okay. So this is 15, 15, 15. You can see this is the descriptive statistics summary. Mean is found to be at the start 68.39. Then after 1 month it is reducing. Then after 2 months, that means the campaign has not been effective. The descriptive statistics is reflecting. That means the not well designed marketing campaign has been that implemented. It seems here as far as means of all these are concerned. Okay, so mean rank simple. It is ranks have been given also. It is 2, then 1.87, then 2.13. Okay. Then test statistics, you can see whether it is significant or not significant. You can see chi-square. What chi-square value tells? You see number of sample. You see 15. Chi-square value is 0.533. Degree of freedom is 2. 3 minus 2. 3 minus 1. It is 2. Okay, 3 groups minus 1. Then this is significant. Significant value, it is 0.766. What does it mean? How to interpret? The campaign has significant impact or no impact?
No impact, sir.
No impact. Okay, very good. Okay, that means the marketing campaign, if you go for a literature review, it has an impact. But maybe they have not designed the campaign very well. Okay. So what happens if you are giving more advertisement of Coca-Cola or beverage product in winter? Because people don't use, there will not be impact, a lot of impact. But if you are giving this kind of advertisement in summer, it is more likely to impact. Okay. So when you design a marketing campaign, you have to see what is the season. Sometimes it's seasons matters. Are you getting or not? Season matters. Okay. So take for example Rakhi. Rakhi, it's a seasonal product. If throughout the year somebody campaigns, then it will incur loss because your marketing campaigns requires money, isn't it? So there are some seasonal products. There are some that throughout years products are there. People are consuming. Okay. Giving advertisement, like for example, during cricket match, because there are a lot of people who see cricket match, that will have different impact. Okay. Than this. And what is more important is that just giving advertisement, because you know the switching behavior of consumers. Like when there is an advertisement, they sense the channel. That also happens. So the advertisement needs to be very catchy. The promotional program, unless it is catchy, that will not be effective. So this advertisement campaign might not be effective because of number of factors. But there is a campaign. The campaign that has been initiated by the company, it has been ineffective. And this has been reflected in the p-value, 0.7. It is greater than 0.05. Got it? This is how you can interpret this. Okay. Is there any concerns or questions? That you can address? Yes.
Participants are requested to ask their questions, or you can write it in the chat box so that I can read it out to sir.
I think there is no questions. That's fine. Okay. I thank you all because uh, you are one. You are the people who gave me the opportunities to recall so many things because we don't do all these things always. We don't practice. Okay. And it is because of you, I also practice, and also because of you, you raise some of the concerns, questions, and also, and these were also very much interesting. Okay. So it is all the way. If you see learning in both the sides. Okay. Thank you. Thank you very much. Yes, over to you, ma'am.
Yes, thank you, sir. So good evening, everyone. As we have come to the end of this session 12 of our day 4, on behalf of BPUT fraternity and all the participants, I would like to extend my sincere thanks to all those who have contributed to make these FDP sessions on hypothesis testing using parametric and non-parametric tests a resounding success. I would like to express our deepest gratitude to our esteemed speaker for his time, Dr. Chandrakanta Sahoo sir, for giving such an engaging session. Your expertise and in-depth knowledge on hypothesis testing, both parametric and non-parametric methods, have greatly enhanced our understanding. We are certain that all participants will benefit immensely from your teachings, both in their academic pursuits and research endeavors. I would also like to thank all the participants for their active participation. Your engagement added great value to this session, and we hope that the insights gained here will help you to apply these techniques effectively in your own fields. Thank you once again, and have a wonderful day ahead. So thank you so much, sir. Today we have come to the end of day 4 of this FTP. So briefing about our day 5, we have 2 sessions in the morning. One will be given by Dr. Vikramaditya Das sir on publishing and presentation skills, and the second one will be taken up by Dr. Soumendra Patra sir on interdisciplinary research approach. And our noon session, that is our 3 p.m. to 5 p.m. will be a valedictory session. So hope to see you all tomorrow at 9 p.m. 9 a.m. Thank you so much for today. Have a wonderful day.
Thank you.
Thank you.